I am Jayakani. I am working as an assistant professor of IT department at St. Joseph Institute of Technology. Okay, today I am going to take a topic on neural network. My agendas are basic structure of neural network, then how neural network will works. Today we are going to discuss about that. So for that, forward propagation, then backward propagation. So now I am going to explain about first basic structure of neural network. Then only we can understand how this neural network will work based on this forward propagation and backward propagation. Okay. Let's we consider three input in the input layer. This is input layer, then next one hidden layer, then last one is output layer. And now I am going to keep one hidden neuron in the hidden layer, then one neuron in the output layer. Then each and every neuron will be connected. This is output. Here input layer will get information from the input data set. So I just consider x1 is one of the input, x2 is another one, x3 is another one. Have you all clear? Very simple thing. This is a basic structure of neural network. This is a single layer neural network. For multiple layer neural network, we'll apply more hidden layers. This hidden layer we can keep based on our input features. Very complicated problem, we can use multiple layer neural network. For basic problem, we can use single layer neural network. So here, very simple concept. There are three layers. One is input layer, hidden layer, output layer. Input layer will get information from the input data sets. These input data sets, raw data, we can't apply the model indirectly. So we have to do some pre-process using NLP concept like that. Then after pre-processing, these inputs will pass to the hidden layer. Hidden layer will do some process. Then after processing, it will do some activation function. In last class already I have discussed. There are two types of activation function. One is sigmoid activation, another one is ReLU activation. So we have to select which activation function is suitable for our problem. For example, classification type of problem, we can use sigmoid activation function. For a regression type of problem, we can use a ReLU activation function. So each and every neuron in the hidden layer will do some activation function. Then it will display the output. Okay. This is a basic structure of neural network. So next I am going to explain about how this neural network will work. It has two categories. One is forward propagation, another one is backward propagation. It's a very simple one. Forward means very simple. Information will get from the input data sets. Then after pre-processing, this input layer, information will pass to the hidden layer. Hidden layers will do some activation function. Then after that, it will pass the output to the output layer. This is a forward direction from input to output. That's why this process will call forward propagation. Okay, as you know everyone, first we have to develop the model. Once if we develop the model, we have to train the model for using this deep learning concept. For example, if we have data sets, 100% data sets means 70% of data sets we can use for train the model. Then remaining 30% of data sets we can use for testing our model. So why we are doing testing here? Then only we know our model will be work perfectly or not. That's why we are doing testing process also. In this testing process we can use forward propagation methodology. After getting output, we should compare that. Already we have that output also in that data set. So we have to compare. Is there any mismatch or any loss is there? We have to find. So forward propagation main concept is to find loss. Okay, for example, actually our predicted output, that means this one, I will consider y hat. Okay, actual output I have considered y. So here in this forward propagation we have to find loss, that is our main. So for loss formula, y minus y hat, this is our loss formula. Very simple one. This is our actual output minus predicted output. Then only we can find how much of loss. Okay, this is a main purpose of forward propagation. Then after finding loss, we should reduce the loss. That is our aim. For reducing loss, we can use back propagation. For backward propagation, sorry, back propagation or backward, both are same. So let's say consider same structure, then only we can get clear idea. Okay, so I just draw here. This is our input layer, then hidden layer, then this is output layer. Each and every neuron will be connected here. We have to assign some weights also. This weight only will decide that neuron will be activated or not activated. Okay, so in between we have to assign some weights. Okay, this is input x1, x2, x3. These are our inputs. I just assign weight. This weight only will be decide that neuron will be activate or deactivate, like that. Okay. For example, this is output 1, this is output 2. Okay, output 1 is nothing but that y. Already we know that formula W I X I plus bias. Already I told, once again I will recall. Bias we should add for processing. Then only we can do that all the process perfectly. That's why we are adding bias. For example, here if we are adding one bias 1 means in the another layer we have to add bias 2. I just keep the name B1, B2, bias 1, bias 2. Same bias we should not use. Okay. Then hidden layer will be differ based on input features or based on application. Okay. Just for example, I just keep only one input layer, one hidden layer, one output layer. Okay. After calculating this, we have to apply activation function. Okay. Oh, I just mentioned like this. Okay. Then afterwards, we have to multiple this O1 and W4. Then only we can calculate this O2. Here also we have to apply activation function. Then we need to add bias. This is 2, this is 1. Okay. Or otherwise I just keep B2, B1. This is O2. Okay. So here up to this I just explained how the neural network works in that forward direction. Okay. Then once if you calculate loss, we have to reduce loss through the weight updation method. Okay. After weight updation, we have to apply chain rule differentiation. These are the main concept of backward propagation. First one is weight updation formula. Okay, then second one is chain rule to differentiation. Clear? So backward propagation is nothing but after complete forward propagation, we have find out that loss, we should reduce the loss using back propagation technique. Back propagation technique has two categories. First one is weight updation formula, we should do that. Then after completing weight updation, we have to do chain rule to differentiation. Okay. So first I will explain how to do weight updation process. Very simple formula for weight updation. First one is W new equal, that means new weight, W old minus learning rate. I will explain what is this. Then derivative of loss by derivative of W old. Okay, already we know that formula. So for example, loss already I told y minus y hat. This is actual value or output. This is predicted value. So this is a main formula for loss, calculating loss. So weight updation formula, this is simple one. W new equal W old minus learning rate derivative loss by derivative of W old weight. This is a very simple formula. Same this formula only will be applied in W1, W2, W3 and W4 also. In backward propagation, we have to do the process in the backward direction. So first we have to update the weight in this W4. Okay. Why we are doing updation? Once if you update the weight, then after that we can reduce the loss. For example, this is global minimum. Okay, now listen. Now our predicted value is here. You just consider left side is negative, right side is positive. So this one, this part, this derivative loss by derivative W old, that means nothing but this is slope. Okay, here first we have to identify positive slope or negative slope. That means, for example, we predicted that predicted values here left side means that is negative slope. Right side means positive slope. Why we have to identify that is a negative slope or positive? It's a very important thing we will discuss now. Listen here, already I told, in case if our slope value is negative, that means W new equal W old minus learning rate, derivative value also negative. That means negative slope. Already I told you no that one. So now minus into minus plus. So W old plus learning rate of that slope value. So what will happen here? Our new weight increase compare with old weight. Clear? So if we have our slope values negative means we just apply that value in that formula, minus into minus plus. So our old weight will be increased, right? Yes, comparatively our new weight will be increased, right? So if negative slope means the weight will be increase. New weight will be increase in that negative slope. Okay, in case if we have positive slope, positive slope means that old weight will be big. So weight new one is will be decrease. Okay, very simple. If our slope value is negative means new weight will be increase. If our slope value is positive means new weight will be decrease. This is a basic concept. Okay. Now I will explain what is that learning rate. Learning rate we have to consider a very small value or big value based on our concept. In case if I have smaller value, our slope value will be in decrease little bit smaller steps. Then we'll reach the global minimum. Our target is, this is our predicted value. We should reach this. Last, we should overcome the loss. So smaller steps will be get and reach the global minima. Okay. In case this learning rate value, if I choose larger value, that means maybe this predicted value will move here to there, here to there, here to there. Maybe it will not reach global minimum. Actually, our target is predicted value, and actually we have to compare. If we find any loss, we should reduce the loss by weight updation method. Okay. In case if we are select a larger value of learning rate, high value means maybe sometimes that value will not reach the global minima. It will move here to there. So better choice, we can use smaller value of learning rate. Then only our predicted value will be move from smaller steps and reach the global minima. This is our target. Okay. Okay. Next, already I told in that back propagation has two categories. One is weight updation, another one is chain rule of differentiation. weight updation completed. Next, I am going to discuss about chain rule to differentiation. Okay, chain rule, it's a very simple one. Once again I will repeat. Forward direction means input layer get information from the input data sets, then will pass to the hidden layer. Hidden layers will do some process and some activation function. Then after it will pass to the output layer. This is the forward method. Then after finding the output, we have to compare with actual value. If we have loss, we should reduce loss by using back propagation methodology. In this back propagation methodology has two categories. One is weight updation. Once if you are update the all weights W4, W1, W2, W3, then after you have to apply in this chain rule differentiation. Okay. For example, W4 means W4 new means W4 old minus learning rate, derivative of loss, derivative of W4 old. Okay, this is a formula already I explained clearly. W4 new. Similarly, we have to update weight W1, W2, W3 also. Okay, so listen here. Now I am going to explain this derivation process. This is a very important process. Here only we are going to apply chain rule derivation. Okay, so derivative loss W4 old. That means, listen carefully. This is hidden layer output 1. This is output layer output 2. So here we have find that loss. So this loss will be based on this O2, then this W4. Okay. First backward direction we are going to apply. So this loss will be depend on this O2 and W4. So we can use the formula derivative of loss by derivative of loss by derivative of O2 into derivative of O2 depends on W4. Derivative of O2 W4. Clear? So this is a formula. Then once if you calculate this, you have to apply in this formula. You will get new weight of W4. Very simple. Only one thing you should remember, this loss will depends on O2 and W4. Okay. Then after this output O1. Okay. So this is a formula for W4. Then next I will explain this O1 for updating the weight of W1. Now we are going to update weight for W1. W1 new equal W1 old minus learning rate, derivative of loss by derivative of W1 old. Okay. So this new value we are going to calculate. So old weight minus learning rate. Already I explained learning rate, very small value you can consider. Then only smallest it will reach the global minima. Then derivative of loss by derivative of W1 old. Okay. So now this one we are going to calculate. Derivative loss by derivative of W1 old equal, now listen carefully, now this loss depends on O2, O2 depends on W4, W4 depends on O1, O1 depends on W1. So this process we are going to do. So listen carefully, it is very important. So first one, derivative of loss by O2 into this derivative O2 by derivative of W4. Okay, then derivative of W4 depends on the O1. Clear? Then this O1 depends W1. This is a formula. Clear? Very simple one. That loss depend on O2. O2 depends on W4. W4 depends on O1. This O1 depends on W1. Similarly, same formula we can apply in that W2 updation, W3 updation also. Very simple. Same thing only. So just we can directly change the number only. Derivative of loss, derivative of W2 old, W2 this old equal derivative of loss by derivative O2, derivative O2 by derivative of W4, derivative W4 by derivative of O1 up to this same. So here only one change. This derivative of O1 depends on W2. Okay. In that weight updation of W3, same thing. This O1 depends on W3. Then afterwards, directly we can apply in this formula. Have you all clear? Already I told what is O1, what is O2. O1 means it's nothing but hidden layer neuron output. Summation of X1, Xi, Wi. That means X1 into W1 plus X2 into W2 plus X3 into W3. We need to add some bias. So then after we have to apply activation function. Each and every neuron in the hidden layer we should apply activation function, whether it's sigmoid or array. Then after getting this output 1, this information will pass through the output layer through the weight of W4. Okay, here we have to calculate output 2. It's nothing but output 1 into W4. Then after multiple this, we have to apply that activation function. Here I have used sigmoid activation function. Okay, then here also we need to add bias. Bias will not be repeated. Each and every hidden layer we have to use a different bias. Have you all clear? This is a backward propagation. Once if you update this all weights, what we have to do? How can we identify our loss has been reduced or not? Very simple. Each and every weights if you are updated, again we have to do forward direction, forward propagation. Same methodology, input values, we have assigned new weight values, same output 1. Then once if you calculate output 1, next you have to calculate this output 2. Then after you have one predicted value. Same last formula you can use, y minus y hat. Y is nothing but our actual value. Y hat is nothing but our recent predicted value. You have to subtract this, you will get loss. That loss value will be reduced. Once if you are not satisfied, again same process will do that back propagation. Again we have to update the weights in backward direction. Once if you complete that weight updation, again you have to check through the forward direction. Then you have to identify loss. That loss will be reduced. For example, our predicted value in beginning first step here means, one second. This is global minima. This is gradient descent. Okay, for example, first time you are calculating predicted value loss here means, then once if you update, then if you do the process, that means it will reduce smaller steps. Then again you have to try, again it will reduce. So again and again we have to do up to reach our global minima. Once if you reach your global minima, your model will be very perfect. You can apply any data, then it will predict that very accurate value. That is our overall conclusion. I think today's session is you have clear idea. I think if you have any doubt, you can ask me in the text. Thank you all.